Welcome everybody. Thanks for joining us again. For today's session, we've got maths that's going to be delivered by Molly. Molly is a computer science and mathematics student at the University of Bath, and she has delivered over 150 sessions with us. So you guys are in safe hands. Over to you, Molly.
Hi guys, welcome back if you've come before. So my name is Molly and I'm going to be leading this session. Today is on highest common factor and lowest common multiple. So if you were here yesterday, this actually leads on really well from yesterday. Don't worry, I'm going to do a really quick recap at the beginning. So yesterday we were talking about prime factorization. So that's where we take a number and we strip it down to its core elements, break it down as much as we can possibly break it down. So just while some more people are arriving, I'll just do a little recap of that. And then I'm going to talk about the most common situation in which we apply this. So let's just start by doing a really similar example to yesterday. So let's say find the prime factors. There's lots of ways of it being worded, prime factors or express as a product of primes or something like that. So find the prime factors of, let's choose a number, 58. So what we do is we take that number, and I always do it as a prime factor tree. So we think of something that goes into 58. So I'd say the most obvious one is probably 2. So we split it into 2. And 29. Oh, I chose one that only, that's a bad example. And then we circle ones that are prime. So actually here, the prime factorization of 58 is just 2 times 29, because both of those are prime. If I choose a better example, something like 84, then again, also this doesn't matter at all which order you split them up. So I normally start with 2, if it goes in, if not 3, and so on. So this splits into 2 and 42. And then 42, I could split it into 2. I actually also know that that splits into 6 and 7, for example. So we can do that. 7 is a prime, so we circle it. And 6 is 2 times 3. So let me know if you want me to go over that again. I've done it quite quickly because I know that we went over it yesterday. So I'll get on to the content of today. And we will be doing this throughout today's session, so don't worry if you didn't understand that completely. So today's session, like I said, is on lowest common multiple and highest common factor, commonly abbreviated to LCM, HCF. You've probably seen them before. So I'll just start by giving a quick explanation of what on earth they are. So let's start off by thinking about highest common factor. So the highest common factor is the biggest, highest number that's a factor of both of them. It's exactly what it sounds like. It's the highest, the biggest factor that is common to both, the highest common factor. So here's a way that you can do it. This is quite a long and arduous process. This one is kind of by hand. And then I'll show you how to do it really quickly with prime factorization. So let's say our question says, let's grab a question here. Find the highest common factor of 24 and 64. So one way that you can do this is write out all of the factors of both of them, see which are common, and then see which is highest. So let's have a look first of all at 24. So what's a factor? 1, 2, 3, 4, 6, 8, 12, and 24 itself. That's everything that divides into 24. The way that I always work these out as well is I start at 1 will always go into it, and then I count up, until I get to one. So for example, here, 4 times 6 is 24. And then you can kind of work backwards. So what multiplies by 3? 8 does. What multiplies by 2? 12 does. What multiplies by 1? 24 does. Maybe that helps, maybe it doesn't, but that's how I think about it. And now let's think about 64. So we've got 1, 2, 4, 8. And now I know that 8 times 8 is 64, so I start working backwards. So 64 is 4 times 16. It's 2 times 32, and it's 1 times 64. So those are all of my factors of 64. And now we circle the ones that are common. So these both have a 1, they both have a 2, they both have a 4, they have a 6, they both have an 8, and nothing else is common. So what's the highest of those? 8. Hopefully that makes sense. Just shout if it doesn't. And again, I'm about to show you a much quicker method of doing this. So, and also it might not seem quicker or easier, but when the numbers get really big, it ensures that you don't miss a factor or anything like that. Someone said, are there 2 8s? Kind of, because it's 8 times 8, but we only write it once. We just write the number if it divides into 64. So let me show you a cool method of doing it. So what we do is we're going to list the prime factors for these. So 24 is going to be 2 times 12. Again, I'm going to do these really quickly, so please do shout if you want me to slow down. But I know people found these quite easy yesterday, so I don't want to bore you. So there you go. That's what this one is. And 64 is 8 times 8. And 8 is 4 times 2. And this is 2 times 2. Same thing here. 64 is a funny one because it's just a power of 2. So basically 24 is equal to 2 cubed times 3. And 64 is equal to 2 to the power of 6. And now here's what we do. Here's the magic part. Is that how I do this is I write them all out like this. So 24 is 2 times 2 times 2 times 3. You'll see why I've left a gap in a moment. And 64 is 2 times 2 times 2 times 2 times 2 times 2. So I'm lining up all of the numbers that are the same, and this will make a lot more sense once I've got more numbers than just 2 and 3. And then what we do is we see which ones are common. So they've got a common factor of 2. They've got a common factor of another 2. So that means they've actually got a common factor of 4. They've got a common factor of another 2. And that's all. We can't, so currently our highest common factor was on 2, then it was on 4, then it was on 8, and we can't make it any bigger. If they shared a 3, we could multiply it by 3. The only things that they share are 3 2s. Because if we multiplied this by 2 again, it would only be a factor of 64. It wouldn't be a factor of 24. And if we multiplied this by 3, it would only be a factor of 24. It wouldn't be a factor of 64. So we can see the ones that we've circled, that's 3 2s. I know we technically circled 6 2s, but it means what I'm just doing is circling what they have in common. So I've circled each 2 twice, basically, to show for each. And that's 8. Hopefully that makes some sort of sense. Don't worry if it doesn't. I'm going to do a lot of examples. I won't move on to lowest common multiple until we've got this down, and then I'll do some mixed questions. So please let me know if that makes sense or if it doesn't make sense. Okay, let's have a look at another one. Let's do this. Find the highest common factor of 75 and 90. So this is what I'm going to be doing some word questions in a bit as well. These ones that we're doing are kind of the basic level where it's just tell you what to do. I'll also be covering, like I said, some word questions. So let's just dive straight in with our prime factorization. If you get it first, work on the chat what you think it is. So let's start off by looking at 75. Now I can see that that breaks down into 25 and 3. Again, if you didn't see that and you just saw that it breaks down into 5 and 15, you can write that. It doesn't matter how you break these down. And then 25 is 5 and 5. And 90, I can see is 10 and 9. 10 is 5 and 2. 9 is 3 and 3. So let's write these out. 75 is 3 times 5 times 5. And 90 is 2 times 3 times 3 times 5. Can you see how I've written common numbers above each other? So I've written all the 2's here and all the 3's here. That makes it a lot easier to see which things they share. Now let's look at what they share. They share a 3 and they share a 5. So if 3 goes into both of them and 5 goes into both of them, 3 times 5 must go into both of them. So the highest common factor here is 15. Okay, cool. A couple of people are saying that this makes sense, which is really good. Someone said that they understand the other way. If you understand the other way, that's really good. This way is basically the other method where you list them all. There's the possibility that you could miss some factors. And especially with these, I don't know if I would have thought of 15 necessarily. So just kind of be careful and give it a go to try to understand this. Cool, awesome. People are getting this, which is really good. Okay, let's have a look at another. Let's have a look at this one. Of 84 and 35. This one will be interesting. Cool, let's have a look at this. So let's start off, break down 84. Let's see what goes into 84. 2 and 42. Oh, this is one that we did at the beginning. And then that 42, I can see is 6 and 7. And 6 is 3 and 2. And then 35, that's just 5 and 7. Those are primes straight away. So let's write those out. 84 is 2 times 2 times 3 times 7. And 35 is 5 times 7. So look at that. The only prime factor that they share is a 7. There's nothing else. We can't multiply this by 2 because then it wouldn't be a factor of 35. We can't multiply it by 5 or it wouldn't be a factor of 84. So the only thing that goes into both of them is 7. Cool. Someone's asked me to slow down, so I'll do another example, but a bit slower. I get too excited about maths, go too quickly. Okay, let's have a look at this one. So here's one that uses the same number. It uses 84. We've got a different number there. So I'll do it again. So we want to find the highest common factor of 84 and 80. So we want to find the biggest number that fits into both of these. And the way that we're going to do that is by looking at the prime factors, all of the building blocks that make them up. So let's have a look. 84, I'll do this one quite quickly because we just did it. So 84 I can see is divisible by 2 and 42. 2 is a prime, so I'm going to circle that because we can't break that down anymore, so I've circled it, I've stopped it. 42, I'll do it another way. I can see that 2 goes into this with 21. 2 times 21 is 42. Again, 2 we're going to circle. We stop that branch. Can't be broken down anymore. And 21 is 3 and 7, and those are both primes. So we've broken down 84 as much as we can into its key parts. Then we're going to do the same thing for 180. So I can see that this is 10 and 18. 10 is always a nice one to spot. Neither of those are primes, so we're going to expand both of these branches. So 10 gives us 5 and 2. Those are both primes. Fab. 18 is 2 and 9. Or we could have done 6 and 3. Doesn't matter at all. It will give us the same thing. And 9 is 3 times 3. So we've broken down 118 to its smallest parts as well. Can't scroll down anymore. I'll do it over here. Someone said, can you go back to the other one? I won't, just because if people have already got it, but this is recorded. So if you're copying stuff down, you can watch it again. So we're going to list these out. So 84 is 2 times 2 times 3 times 7. I've written a gap here because I know that there's some 3s and 5s that we're going to have to put in. And then I'll write down 180. So 180 is 2 times 2 times 3 times 3 times 5. So all I've done is these blue ones here are what multiply to make 84. And these green ones here are what multiply to make 180. So what we're saying is we've stripped them down to the same elements, to those core primes. And any factor of either of these things can be made up by multiplying the prime factors. So any factor of 84 is a combination of these. So 6 is a factor, 2 times 3. 14 is a factor, 7 times 2. 42 is a factor, 2 times 3 times 7. 21 is a factor, 3 times 7, and so on. Any combination of these is a factor, and any factor is a combination of those. So that means if we can work out what numbers go into both, which primes, and combine them all together, then we're going to get something that goes into both of them. I probably worded that quite badly. So if we have a look here, what lines up, these both have a 2 in it. So 2 is a common factor of both of these. But we can do better than that because they also both have another 2, which means that 4 is a common factor. Because if 2 goes into both and another 2 goes into both, then 4 goes into it. And we can do better than that as well. We can see that these both share a 3, which means that 2 times 2 times 3 is a factor of both of them. Because a 2 goes into both, and another 2 goes into both, and a 3 goes into both. And we can't do anything else. If we were to multiply this by 7, it would no longer be a multiple of 180, because 7 isn't an element of that. It's like if you add, I was using the analogy yesterday of water, how it's 2 hydrogens and an oxygen, and that's what you strip it down to, and that's what you kind of smush together to make water, right? If you add carbon to water, it's not water anymore. It's become a different element. It's probably not how chemistry works, but the analogy still pretty much holds. If we try multiplying this by 7, it no longer fits here. So our solution, as people have quite rightly said, is going to be 2 times 2 times 3, all of those shared primes, which is 12. So 12 is the highest factor that's common to both of these numbers. Hopefully that makes sense. I'll go over one more before moving on. In fact, I know what I want to go over. I'm going to come up with one. Find the highest common factor of, let's see, I'm going to do 35 and 12. Okay, so let's do what we've been doing. So 35, this is 5 times 7, and both of those are primes. That's what we've broken this down into. 12 is 3 times 4. 3 is a prime, but we can break 4 down even more. We can break that into 2 and 2. So let's write these out. 35 is 5 times 7. 12 is 2 times 2 times 3. What do you think the highest common factor of these is? Just whack it on the chat. Yeah, a couple of people have got it already. See if anyone else wants to give it a go. And then I'll go through why. Okay, cool. I'll go through this one. Yeah, a couple of you got the right answer. It's going to be 1. Because we have nothing, no common links. We can't even multiply by 2. So what have we left with if we multiply by nothing? 1. That's all we have. That's what you start with when you multiply, right? And if you want to think about it another way, there's absolutely nothing that fits into both of these apart from 1. 1 goes into everything. So if there are no common factors here at all, the highest common factor is just 1. And if anyone's a nerd like me and wants to learn a new word, that means that you don't need to know this. So feel free to completely ignore what I'm saying. But 12 and 35 are co-prime. Just if you want to know a word, I think it's always good to throw in some cool terminology. You don't need to know that. But if the highest common factor is 1, then they're co-prime. None of their primes match up at all. There you go. If anyone wants a, someone said they like it, so that makes me happy. Always good to learn a new word. Okay, cool. So if you still have any problems with this, just whack a question on, hang on till the end, because I will be going over some more questions. I'll be doing lowest common multiple, then some word questions. Okay, cool. Now let's talk about lowest common multiple, LCM. Now this is a similar kind of thing, but in this case, it's the smallest number that is a multiple of both of them. So, for example, let's think about, I'm going to do it with some slightly smaller numbers this time. I'm going to think about 6 and 8. So let's do it again the long way. So let's write out, what are the multiples of 6? Now, there are infinite multiples of anything, right? Because we just keep doing multiples. 6, 12, 18, 24, 30, 36, blah, 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 36 million, 36 billion, so on. So we're not going to list all of the multiples, because we would literally be here forever. We're just going to list maybe 5 and then list a few multiples of 8 and see if you hit one. Because it's the first one that you hit that's in both of them, we'll just do it in little chunks of each. So for 6, let's list some. So we've got 6, 12, 18, 24, 30. Let's just list up to there and then list with 8 and see what we get. 8, 16, 24. Ooh, 24 has appeared. And that was in this list too. And because this is the lowest one, it's 24. 24 is the smallest number that both 6 and 8 multiply to get. This is a really useful method as well for, you know, when you add fractions, you want to make the denominators the same. Without realizing it, you probably make the denominators be the lowest common multiple. If you add a 6 and an 8, you'd want to put them over 24. And the other thing is, the lowest common multiple, the highest it can be is this times this. So if you want to, just list the multiples up to that. I'll give you an example of that. Let's say, let's do 5 and 8. Lowest common multiple of 5 and 8. So 5, we have 5, 10, 15, 20, 25, 30, 35, 40. 8, we have 8, 16, 24, 32, 40. So you see the smallest here, and you'll understand why in a moment once we do it with prime factorization. But it's 40, which is equal to 5 times 8. So you'll never have to go past that. And you'll probably know that as well from when, again, if you were adding a 5th and an 8th, you'd want to do it as something over 40, because you know that that's a multiple of both of them. So even if you don't explicitly know that you're doing it, you'll be familiar with this. Now, this is great, but it can be a little bit time consuming. And what if we had huge numbers? What if we had, like before, 12 and 35? Because they're co-prime, the highest is actually going to be equal to 12 and 35, 12 times 35. And I definitely wouldn't want to write out 35 multiples of 12. So I'm going to show you a foolproof way to do it using prime factorization. Let's just do it with 6 and 8, because we know what the answer is for that. They're small numbers. We'll just see it done in a different way. So we know that what we're looking for is 24. So that means that we can check this method, check that I'm not lying to you. So we're going to do prime factorization trees, my favorite. So these are quite easy because they're small. So 6 is 2 and 3. And 8 is 2 and 4. And then we can break down 4 even more into 2 and 2. Now we're going to do what we did before. 6 is 2 times 3. And 8 is 2 times 2 times 2. Now, here's what we're going to do. We could very well, so a multiple, let me try to, I don't want to just like tell you the method, I want you to understand it. So I'm aware that some of you might get confused, but I'm going to do a lot, so hopefully it makes sense. So a multiple of 8 is going to be 2 times 2 times 2 times something, right? Times anything, times 57, times 4, times 25, you know? That's what it means. And a multiple of 6 is 2 times 3 times something. 2 times 3 times 10, 2 times 3 times 1,000,004, and so on. And what we can see is that because, so I can even write that out here. So it's a multiple of 6 here is 2 times 3 times something. A multiple of 8 is 2 times 2 times 2 times something. So that means that the lowest of that is where that something is 1, right? The smallest multiple. And now they both share a 2. So instead of doing 2 times 2 times 2 times 2 times 3, instead of just multiplying 6 and 8, which is a multiple of both of them, that is a common multiple, but it's not the lowest. Why don't we just use this 2 once? This 2 is kind of shared. If you want to think about it like this, you've got 2 times 3 to make a multiple of 6, and 2 times 2 times 2 to make a multiple of 8. This big 2 here is shared between them. I hope that makes sense. Because they both involve a 2, why not make it the same 2? Hopefully that makes sense. Some people are like, oh, someone said, that's actually very smart. Someone said, won't 0 be the lowest common multiple? I guess technically, yeah. Or I guess the lowest common multiple actually could be a negative number, right? Negative infinity. So I think we define a lowest common multiple as a greater than 0 multiple. Don't worry if you're not following at the moment. I think a couple of you are, which is really great. What this means then is because we've shared that 2, it's going to be exactly what this is. 2 times 3 times 2 times 2, which is equal to 24. If you ever get lost and you just want to remember a straight kind of thing to do, circle all the ones that are common and then multiply it all together, but just multiply the circled things once. So because I've circled 2 and 2, imagine smushing those 2's together. Right? So you just circle this. So we do 3 times 2 times 2, and then we just count this as 1, 2, because we've circled it. Hope this is making some sort of sense. Someone said if you have 2 prime numbers and you have to find the lowest common multiple of them, That's what I was saying before. This will be when it's just the 2 multiplied. So say we have 5 and 7, the lowest common multiple will just be 5 times 7. The actual question that someone said, let me pop it on here for you, because it is a good one. A and B are different prime numbers. Find the lowest common multiple of A and B. If they're prime numbers, they don't share any primes. So they don't share a 2 or anything. We can't overlap it. So the lowest common multiple is just AB. It's like if we have 3 and 5, they don't share anything. So it's just, yeah. Okay, cool. Let's just have a go at a few lowest common multiple questions, because I know that this is really difficult. I don't want to get used to it, but I'm fully aware that it's a really difficult one to get used to doing. So find the lowest common multiple of 24 and 36. See, this is where this is really useful. I don't want to be writing out my 36 times table. So we're going to use this prime factorization method. And I'll show you one. In fact, I think the first word question I'm doing uses huge numbers. So there's no way we'd want to be doing that. So 24 is 12 and 2. I don't know why I did it this way around, that's weird. Which is 3 and 4, and 4 is 2 and 2. And then 36 is 6 and 6, which is 2 and 3 here, and 2 and 3 here. So that's the, hopefully by now, easy bit. Do shout if you're still struggling with that, because if that's what's holding you back, that's easily rectifiable. So let's write out 24. 2 times 2 times 2 times 3. And 36, 2 times 2 times 3 times 3. Now, I'm going to kind of maybe write this in a bit of a different way, actually. So what I'm saying is that any multiple of 36 is 2 times 2 times 3 times 3 times something. And 24 has 2 times 2 times 2 times 3 times something. So let's see which ones are common and just share it. So instead of both having a 2 here, if we're making a multiple, let's share the 2. And instead of both having a 2 here, let's share it. And instead of both having a 3 here, let's share it. To get the lowest common multiple, we want to share as many of the numbers as possible. And now, look what we've got here. 2 times 2 times 2 times 3 times 3. So we've got 2 times 2 times 2, 72. Do that. And that's our lowest common multiple. Yeah, a couple of people got that, great. Someone asked when the session ends, it ends at 1:15. Yeah, the other way to think about it, if we write this out in index form, scary maths term, it just means with powers. So if we wrote this as, we wrote this one as 2 cubed times 3, and we wrote this one as 2 squared times 3 squared, so writing these, to get the lowest common multiple, we think about the highest of each power of them. So the highest power of 2 here is 2 cubed, and the highest power of 3 is 3 squared. So we do 2 cubed times 3 squared, which is exactly what we did there. That helps if the numbers are huge. If you've got like, I don't think you'd ever really get that, but if you want a quicker way of writing them out, that's how we can do it. Don't worry if you're still confused, I'm going to do some more examples. I think the best way to aid confusion is to do lots of examples. Let's do this one. Find the lowest common multiple of 56 and 98. Oops. There we go. Okay. So have a go at doing it yourself if you understand. Someone said the highest common factor was much easier. It is. I agree. I find it easier as well. But unfortunately, we have to do both. But that's why I started with highest common factor. So if you get that, this is a kind of similar way. Oh, someone just had a question about this. They said, shouldn't it be like with 4 2s? No, because there are only a maximum of 3 2s in either of them. So there shouldn't be 4 2s in it. That makes sense. And hopefully, like I said, it will make sense. So let's give this a go. Right, 56. 56 is 7 times 8. 8 is 2 times 4. 4 is 2 times 2. 98, that's 2 times 49. 49 is 7 times 7. Cool. And if you can do that bit, then well done, because that's hard as well, the prime factorization. So don't feel discouraged if you're still a bit confused with the other stuff. So let's write them out. So 56 is 2 times 2 times 2 times 7. And 98 is 2 times 7 times 7. So what I'm saying is that we could find a common multiple by doing, so I'm going to try to re-explain it as I'm doing it. So we could do a common multiple by just doing 56 times 98. I don't want to do that color. Times 98. That's going to be a common multiple, right? Because 98 56s are definitely a multiple of 56, and 56 98s are definitely a common multiple of that. So we could do that, but we can definitely get lower. So this is equivalent of saying, let's do 2 times 2, oh my gosh, if I could write it would really help, wouldn't it? 2 times 2 times 2 times 7. That's just what 56 is, stripped to its core elements, times 98, 2 times 7 times 7. That's what this is saying. That is one way that we could do it, for sure. But look at this, we're multiplying by 2 here and here. Why don't we just multiply by 1, 2? Because if we get rid of a 2 and a 2 and make our answer just involve 1, 2, then that 2 can be both of those. There's no point, maybe I'll re-explain it again with some smaller numbers, but there's no point in multiplying by 2 twice when you don't need to. That's only going to make the multiple twice as big. And similarly here, we're multiplying by 7 here and 7 here when there's no need. Because if we just multiply by 7 once when we're coming up with our multiple, that can fill in both of them. So that's what I'm saying here. When we circle these, they share a 2 and they share a 7. So this number is going to be 2 times 7 or 14 times bigger than what we actually want it to be. So basically, what you need to remember is circle the ones that are common and just use it once. So when we do our answer, we're going to use a 2 once from there. And then we're going to do it. I'm just going to write all of mine like this. Hopefully the color coding will help you to see it. So we're just going to add that 2 that's circled in orange. We're just going to use it once. We don't need to use it twice. They can share it. But we do need to multiply by 2 more 2s just to make it a multiple of 56. So times 2 times 2. And then they can share this 7 as well. They've both got a 7 in them. Why don't they share it? And then we do have to multiply by another 7 to make sure that it's a multiple of 98. So, I've just thought of something that maybe might make it make sense. If we think about our 56 in pink, let's think about, so this is going to be our answer. And this answer, within it, we've got 56 because we've got 2 times 2 times 2 times 7. So 56 is in this. And then if we think about our 98 in purple, we've got 2 times 7 times 7. So 98 is in this. So in this calculation, hides both the numbers 56 and 98. So it's a multiple of both of them. I think maybe that might make more sense. I'm going to show you this on the next one that I do. Maybe it makes sense, maybe it doesn't. Four of you have got the answer, so well done. And then, yeah, this will give you 392. So again, I definitely would not want to be writing out my 98 times table. So this is a much better method, more efficient method. Do let me know if that makes sense or not. It's basically the smallest combination we have that has both 56 hiding in it and 98. The smallest combination. And what I'm saying by sharing the two is that there's no point in having it okay. I'm really just trying to make sure that everybody watching it can get this. So what I'm going to do actually, just really quickly, is think about this. So if we, you know how we said that could be an option, right? If we just take 56 and we times it by 98. So that's all I've done there is I've written out 56 times 98. Well, let's circle where our 56 is. It's here, 2 times 2 times 2 times 7. Let's circle where our 98 is. It's 2 times 7 times 7. Okay, so all of those circled numbers are multiples of 56 and 98. So why on earth are we multiplying it by 2 and 7 again? No point. Maybe this makes more sense. I don't know. I've done it a million different methods. If you've understood one of them, great. Ignore everything else I've said. Right, I've just got 5 minutes before I'll take questions. I'm going to try doing some word questions. But if you want me to go over this again, pop it on the chat and I'll come back to it when I take questions. So, ooh, can't copy that yet. My face is in the way. Here we go. So these word questions are a mix of highest common factor and lowest common multiple. So this is what I mean by this one has some big numbers in it. So Harry has 2 planks of wood, 756 centimeters long. That's definitely not, you know, and 1,134 centimeters long. He wants to saw them into smaller pieces of wood for his craft. And they must all be of equal length with no wood wasted. So he wants to chop them into equal bits. What's the greatest length that he can saw them into? So what do you think this is dealing with? What method do you think we can apply here? Yeah, exactly. At least one person's got it, and the rest of you might be typing. It's highest common factor. And the reason is because if we've got the, here's a 756 centimeters long piece of wood, and here's a 1,134 centimeters long piece of wood. We want to think, well, we could chop this 756 all into 2 centimeter bits. We could chop it into other bits, but we want them all to be the same. So we want the biggest number that fits exactly into both of them. Hopefully that makes sense why we're doing that. So let's break these down into their prime factors. Hopefully this is a bit easier because it's back to highest common factor. So let's break this down. So 756. I can see that there's a 2. And, oh gosh, 378. I'm actually going to use a calculator so that I don't look like an idiot or tell you anything wrong. Okay, 378. And then 378 also has a factor of 2. And I'm just going to not even try. 189. 189. This is quite a hard one to break down, actually. This has a factor of, it has a factor of 3. Because if you remember the trick from yesterday, when we add up all the digits, they equal a multiple of, in fact, they equal a multiple of 9. So let's do this even better. Let's divide this by 9. All of this that I'm doing on the calculator, you could do fairly easily, very easily using the bus stop method. I'm just doing it here for time. So that's 21. 9 is 3 and 3. And 21 is 3 and 7. There you go. And then 1,134. Gosh, well, 2 goes into this. and 567. I hope. Oh gosh, I'm just going to have to check it because I'm so worried about doing some mental maths wrong. Okay, yeah, I just trust myself. 567. They add up to a multiple of 9. So 567 divided by 9, that's 63. 9 is 3 and 3. 63 is 9 and 7. And then that 9 is 3 and 3. So sorry, that was a bit of a long one. It's because the numbers are so big. And you can see here, we definitely wouldn't want to be listing all of the factors of 1,134. So that's why this method is really necessary. So let's list what these are. So 756 is 2 times 2 times 3 times 3 times 3 times 7. 1,134 is 2 times 3 times 3 times 3 times 3 times 7. Remember, this is highest common factor, so we want just the factors that are common. So that's a 2, 3, 3, a 3, and a 7. So we have 2 times 3 times 3 times 3 times 7, because those are all of the things that they share. So we're allowed to do this. And that is going to give us 2 times 3 times 3 times 3 times 7, 378. So we can chop these bits of wood into chunks of 378 and have them all the same. The website that I'm using, this one is Maths Made Easy, which I bang on about all the time. This one here is, I think, on it's just GCSEMathsWorksheets.com. There you go. Okay, so I've just run over a little bit into time for questions. So, Walla, are there any questions that I've missed that you want to go over?
Sure. There's some questions regarding other methods that can be used. So there's one pertaining to Venn diagram, and there's one that's just generally asking for other methods.
Okay. Venn diagram method. I assume that you mean for, oh, okay. I think I understand what you mean. So let's think about it for this one. If we think about, I've never actually heard of a Venn diagram method, but I'm going to assume that this is what you mean. I'm going to make those overlap a bit more. So we'll have here as factors of, what are these numbers? 7, 5, 6. And here factors of 1, 3, 4. So the ones that they share are 2, 3, 3, 3, 7. And then this has a 2 and this has a 3. So then for highest common factor, you multiply everything in the middle, because it's everything that's shared. That's the same as circling these and doing them. And then for lowest common multiple, you would do, oh, I guess you just multiply all of them together, because then you're only kind of writing out these ones once. So yeah, if people have used that, maybe that makes more sense. I've never actually seen that before, but that does make sense. If you'd rather write these in a Venn diagram rather than on top of each other, go for it if that makes more sense for you.
Fantastic, thanks for that, Molly. There's also another question that just wants a quick summary of the definition for lowest common multiple, like just a quick meaning.
Okay, actually. Sure. I'll give you the definition for both of them, because I may as well, so that you have them both if you want to write them down. So lowest common multiple is the smallest number that is a multiple of both A and B, where A and B are the numbers in question. And our highest common factor is the largest number that is a factor of both A and B. So they really are kind of defined in what they are, which is quite nice. Hopefully that makes sense.
Amazing, that's great. There's another question that asks whether there's such a thing as a highest common multiple and a lowest common factor.
Oh, that's a good question. Okay. The The lowest common factor will always be 1, because that's the smallest number that divides into both of them. Both of these things, by the way, are fairly useless, but interesting. So lowest common factor will always be 1. And a highest common multiple will be infinitely large. Because if you think about, if we have, say, 2 and 3, every multiple of 6 is a multiple of both 2 and 3. So you could have 6 million, 6 billion, 6 trillion, and so on. So highest common multiple doesn't really exist, unless you just call it infinity. And lowest common factor is 1. Good question.
I think someone's just asking about what the quickest method they can employ is as well.
The prime factorization. And I would say, the quickest one is writing them out in terms of indices, like I said. But I think that's also can be quite confusing. So the quickest method is either of these. Venn diagram, list them like this. As long as you do the prime factorization, that's always quicker than writing them out.
Amazing. I think we've got some new questions in the chat as well, actually.
Okay, yeah. Oh, someone's asked about for 3 numbers. I can go through a question like that. The question we just did was it highest common factor? Because if it is, why does it have the same method as lowest common multiple? I'll just talk quickly about the differences between the methods. So with this one, it was highest common factor because as you can see, it's something smaller than them, like it's the highest factor. It's the same method in that you always write them out and circle the ones that are shared. Basically, if we think about it in terms of the Venn diagram, highest common factor is just the bits in the middle. Lowest common multiple, you also multiply it by stuff that's on the outside. That's the difference. It is a really, really similar method. So I used to get super confused in the moment between which one I was actually doing. So just, yeah. Shall I go over one with 3 numbers? That was a question. Go over one like that. Okay. So someone's asked about finding it between three numbers, whether that's the same method. Yes, it is. I'll show you. So let me come up with a question. What should we do? Let's do lowest common multiple because it's a bit harder. What's the lowest common multiple of 8, 14, and 21? Do I want to do that? Who knows whether I want to do that or not, but I am now. Okay. I don't know if this will be a nice question or not, so apologies if it's not. In fact, yeah, okay. So 8 is 2, 2, and 2. 14 is 2 and 7. And 21 is 3 and 7. So let's write all of those out. So 2, 2, 2, 2 and 7, 3 and 7. Okay. I'm going to use the writing them all out and multiplying method. So one thing that could be a factor is 2 times 2, so 8 times 14 times 21, right? So we don't actually necessarily need to write this out for this. Oh, I don't know why I wrote 21. I meant to write times 3 times 7, right? So this is something that could be a multiple, but we want the lowest common multiple. So let's think here. Where's 8? Here's 8, 2 times 2 times 2. Where's 14? Here it is, 2 times 7. And where's 21? Here it is, 3 times 7. Always circle the same a number that's already been circled where you can. Now we can see that this 2 and 7 aren't being used. We don't need them to make up all of these numbers. So here our solution would be just these numbers that have been circled. 2 times 2 times 2 times 7 times 3, which is equal to 2 times 2 times 2 times 7 times 3, 168. So that's how you do it for 3 numbers. I'm going to do, I've got 5 minutes, so I'm going to do 1 highest common factor with 3 numbers and then a word question for lowest common multiple. And that's what's been asked for. So let's see. Right. What is the highest common factor of? This is where it gets quite difficult. Okay. 42, 30, and sorry. I'm just going to work something out. It's really difficult. Oh, okay. No, I know what I can do. And 18. That's what we're going with. These are smaller numbers, so this you can do by listing as well. But I'll show you this method. So that's a big pen, isn't it? So 42, that's 6 times 7, and 6 is 2 and 3. 30, that's 2 and 15, and 15 is 3 and 5. And 18, that's 2 and 9, and 9 is 3 and 3. What I'm going to do here is a slightly different method, just in case this one didn't make any sense. Let's pick all of the ones, if you imagine these as like cherries on a tree, and we'll pick all of the identical ones. So 2 goes into all of these. So we can have 2 in our factor. 3 goes into all of these. So we can have 3 in our factor. 7 doesn't go into all of them. 5 doesn't go into all of them. And 3 doesn't go into all of them. We could also say this was 3 and 3 here. We couldn't do that. It has to go into all of them in a factor. So here, the highest common factor is 6. So they're really similar methods. If you want to see that with a Venn diagram, somebody did. Oh gosh. Beautiful drawing. So let's have 42, 30, and 18. All of them have a 2 and a 3. Then 42 has a 7, 30 has a 5, and 18 has a 3. Unfortunately, there's none in these bits, but even if there were, you wouldn't count them. Highest common factor, we only think about the middle intersection. Hopefully that makes sense. And if you want to see, actually, this could be useful. A Venn diagram for, oh gosh, where did I do it? I can't find where I wrote it on the page. Where did I do it? Oh gosh. I want to find where oh, here we go. I found it. If you want to see this as a diagram, a Venn diagram, and then I'll do a word question. It might run over a tiny bit. We've got 8, 14, and 21. Let's see. Right. They each have a 2 in them. Oh, no, they don't. 8 and 14 have a 2. Then 8 has another couple of 2s that isn't shared by anything else. 14 and 21 have a 7. And then 21 has a 3 that isn't shared by anything else. So here are all of the numbers. And then if you remember, for lowest common multiple, we take everything. So 2 times 2 times 2 times 7 times 3. Same thing, 168. So hopefully that makes sense, what that is. What I'm going to do is I'm not going to go through a lowest common multiple word question because I don't have time. I'm just going to show you the question and explain why it's lowest common multiple. So here we go. For example, this one. Jack is organising a party and needs to buy napkins and paper plates. Napkins come in packs of 175 and paper plates come in packs of 70. He needs exactly the same number of napkins and paper plates with none left over. What's the minimum number of packs he must buy? So this is a lowest common multiple question because if you think it's got to be a multiple of 175, it's got to be a multiple of the packs of paper plates, and it's got to be a multiple of 70, it's got to be a multiple of the packs of, oh, sorry, first 175 is napkins, this one's paper plates. So it's the lowest common multiple of 175 and 70. the minimum amount that you can buy that's a multiple of both of these packs. Hopefully that makes sense. Sorry, that was a bit rushed at the end. I hope everything made sense. Maybe watch the video again. I really recommend Maths Made Easy has solutions as well. So check that out and find some word questions as well. The link that I used here, GCSEMathsWorksheets.com. I just typed in LCM and HCF word questions. I'd really recommend them.
Amazing. Thank you very much, Molly. And thank you all for joining us. That's it for this session. Have a lovely rest of day, guys. Bye.
Hi, everyone. Thank you for coming.